Hello students, welcome to Learn Guru classes. So today we have come again with solution and practice series. So today we are going to solve exercise 1C of R.S. Agarwal. So this particular exercise deals with rational as well as irrational numbers. So to solve the problems from this exercise, you need to know what are rational and irrational numbers and how to identify those numbers and what will happen if you mix two irrational numbers together, or what will happen if you mix one rational number and an irrational number. So these type of variety of problems we are going to solve in this exercise. So let's get started. Before solving the problems, you should identify what are irrational numbers. So irrational numbers are those numbers that cannot be expressed in the form of P by Q. Okay. So irrational numbers can appear in the form of non-terminating and non-repeating decimal expansion like this. Okay. So here if you see, there is no scope that the decimal numbers will come to an end. These numbers will come to an end, as well as not a proper sequence is being maintained. Okay, so this type of numbers are called as irrational numbers like this 0.321,456,84,32231. So here not a proper sequence is being maintained. Next is 0.34344,344. Here also a definite sequence of numbers is not being maintained and it is not being repeated. So this type of numbers are irrational numbers. Whereas square root or cube root of positive integers are also irrational numbers like root over 2, root over 5, root over 3, root over 6. All these are irrational numbers, as well as cube root. Suppose 3 root over 3. So this is also an irrational number. Suppose you are given a number root over 27, and if you are asked that whether it is a rational number or an irrational number, so this can be written as 3 3. So 3 by 2, yes, it's an irrational number. But if it is given that cube root of 27, so that will be a rational number, because ultimately the cube root would have been removed and you will be left with only one number, that is 3. So these are the ways by which we can identify a rational number. Whereas how to identify rational numbers and what are rational numbers has already been solved in exercise 1B of R.S. Agarwal. If you have any doubt, you can refer those problems. So now let's get started with our numericals. The first question is, what are irrational numbers? How do they differ from rational numbers? Give examples. Okay. So just you have to write down the definition. So any number that cannot be represented in the form of P by Q is an irrational number. Irrational number. So irrational numbers can be square root or cube root of any number, or else it can be non-terminating and non-repeating decimal expansion. How do they differ from rational numbers? Whereas any number that can be represented in the form of P by Q, where Q is not equal to 0, are rational numbers. Give examples. So example can be, example of irrational numbers are root over 2, root over 3, 1.3, 1, 2, double 3, 2, double 2, triple 1, 3, triple 2. So this is an example of non-terminating and non-repeating decimal expansion. So these are irrational numbers. The second question is, classify the following numbers as rational or irrational. Give reasons to support your answer. Okay, so the first one is root over 3 by 81. So let's try to reduce this. So 1 by 27, you can reduce it. So 1 root over 1 by 27. So that you can write it as 1 by 3 square into 3, that is 1 by 3 root over 3. Okay, so root over 3 is an irrational number, isn't it? And 1 by 3 is a rational number. So that will always give you an irrational number, because since root over 3 is an irrational number, so that will give you an irrational number. So root over 361. So root over 361 can be written as 19 square. So if you remove the root, so 2 and half gets cancelled, so 19. So 19 is a rational number. Since 361 is a perfect square. Okay, root over 21. So root over 21 can be written as root over 3 into 7. So root over 3 into root over 7. So root over 3 is also an irrational number. Root over 7 is also an irrational number. So that will give you an irrational number. Why? Since product of two different irrational numbers will give an irrational number. The fourth question is root over 1.44. So root over 1.44 can be written as 1.2 whole square. So this is 1.2. So 1.2 is a rational number. So since 1.2 is a terminating decimal expansion, therefore root over 1.44 and 1.44 is a perfect square, therefore is a rational number. The fifth question is 2 by 3 root over 6. So root over 6 can be written as root over 2 into root over 3. So this 2 root 2 and 3, if you it will get you as root over 3. 2 root 2. Yes. So that root over 2 is an irrational number. Root over 3 is an irrational number. So that will give you an irrational number. The sixth question is 4.1276. So this is a terminating decimal expansion. So since 4.1276 is a terminating decimal expansion, therefore 4.1276 is a rational number. The seventh one is 22 by 7. So 22 by 7 is a rational number because since 22 by 7 is in the form of P by Q, therefore it is a rational number. 1.232333332. So this is a example of irrational number because not a definite sequence is being followed over here. So since 1.2323332 is a non-terminating and non-repeating, therefore it is an irrational number. Okay, the ninth question is 3.040040004. Again same thing, since 3.040040004 is a, I'm not writing the full form, non-terminating and non-repeating decimal expansion. Therefore, it is an irrational number. The 10th question is 2.3565656. Okay, so this sequence is being followed. Okay, so since 2.3565656 is a non-terminating but repeating decimal expansion, therefore it is a rational number. Okay, next is 6.834834. so since it is a, this is also a definite sequence of numbers is being followed. So since it is a non-terminating but repeating decimal expansion, therefore 6.834834 is a rational number. The third question is, let x be a rational number and y be an irrational number. So is x plus y necessarily an irrational number? Give an example in support of your answer. Okay. So let's check. So x be a rational number. So let x be 2 and y be an irrational number. Let it be root over 3. So if I just add these two rational and irrational number, So what will be the outcome? So the outcome will give you an irrational number. Okay. So let's check. Suppose 2. If we add this 2.0000 something like that. Root over 3, the value of root over 3 in terms of non-terminating, non-repeating decimal expansion is 1.732, and the rest I don't know what will be the values. Okay. So that's 3.732 something like that. So that will also give you a non-terminating and non-repeating decimal expansion. So it always that x plus y will always give an irrational number. Okay, so here you give irrational number. Next is, let A be a rational number and B be an irrational number. So is A B necessarily an irrational number? Justify your answer with an example. So let's check once again. So A, let's give us as A equal to 2 and B equal to root over 3. Now if we multiply this, what will happen? 2 into root over 3. So again, root over 3 is 1.732, and if we multiply this with 2, okay, so the product that will get, the result that you will get, so that will also give you a non-terminating and non-repeating decimal expansion. So this is an irrational number. Irrational number. So therefore, if A is a rational number and B is an irrational number, so therefore AB will be an irrational number. Fifth is the product of two irrational numbers always irrational? Justify your answer. Okay, so for this let us take two examples. Okay, you decide which one you want to represent the answer in what possible way. I will show you two ways. Okay, so A equal to 2, B equal to root over two irrational numbers. So A equal to root over 2 and B equal to root over 3. So A into B, if you give root over 2 into root over 3, so that is root over 6. So root over 6 is an irrational number. Okay. But if we just replace A equal to root over 2 and B is also root over 2, so A into B, that is root over 2 into root over 2 will be 2. So see here, both of these two are irrational numbers of the same irrational number. So the product will give you a rational number. Okay. So not always, because product of two similar irrational numbers will give a rational number. The sixth question is, give an example of two irrational numbers whose difference is an irrational number. So let's take the two examples as A equal to root over 3, B equal to root over 2. So if I do A minus B, so that will give you root over 3 minus root over 2, that will yield you an irrational number. Okay. difference is a rational number. So for that, let's take a equal to root over 3, b equal to minus of root over 3. Okay, so that if you just a equal to root over 3, b equal to root over 3, same number. Okay, so a minus b, if you do root over 3 minus root over 3, so that will give you 0. So 0 is a rational number. Sum is an irrational number. So sum is an irrational number. Same example, let's take a equal to root over 3, b equal to root over 2. So a plus b, that is root over 3 plus root over 2, will give you an irrational number. Okay, sum is a rational number. So for that, a equal to root over 3, b equal to minus root over 3. So a plus b, if you do root over 3 plus of minus root over 3, so that is 0. So 0 is a rational number. Product is an irrational number. So a equal to root over 3, b equal to root over 2. So a into b, root over 3 into root over 2. So that is root over 6. So root over 6 is an irrational number. Product is a rational number. So a equal to root over 3, b same number. B is also equal to root over 3. So a into b, if you do root over 3 into root over 3, will give you 3. So 3 is a rational number. Okay. The seventh one is quotient is an irrational number. So for that, let us take a equal to root over 15, b equal to root over 3. So if we divide a by 3, root over 15 by 3, so this will give you 5. So root over 5, so root over 5 is an irrational number. Quotient is a rational number. So for that, let's take a equal to root over 12. So 12 is also an irrational number because 12 can be represented as, if you factorize 12, 2 square into 3. So if you bring 2 outside the root, 2 into root over 3. So again, it is a product of rational number and an irrational number. So it will give you an irrational number. So root over 12 is an irrational number. And b, let's take 3. So a by b, root over 3. So if I take root over 12 by 3, so that will give you 4. So 4 is a perfect square, 2 square. So that will give you 2. So 2 is a rational number. Question number 7 is examine whether the following numbers are rational or irrational. So 3 plus root 3, 3 is a rational number, root 3 is an irrational number. So it will give you an irrational number. Okay, so root over 7 minus root over 2. Root over 7 is an irrational number and 2 is a rational number. So that will also give you the difference between the two will give you an irrational number. Okay. Now third one is root over 5 into root over 25. Now root over 5 is an irrational number. But root over 25 is a perfect square. Okay. So let's check. So root over 5 can be just in place of root, we can just replace it with 5 to the power of half. And root over 25, that is we can just give as 5. Okay. So 5, because root over 5 square, so half getting cancelled. So 5 half into 5. So 5 half plus 1. So 5 3/2. So it is coming as 3 cube root of 5. So that will give you an irrational number. Next is root over 7 into root over 343. So root over 7 is an irrational number, and root over 343, let's check. Okay. So root over 7, root over 343 is this. Okay. So the product of them will yield you what? Let's check. So 7, root over 7, you can replace it with half, and say cube root of 3, that you can replace it with 3/2. Okay. So according to the law of indices, you can give half plus 3/2, that is 7 to 4. So it is giving you as 49. So 49 is a rational number. So that is a rational number. Okay. Next is root over 13 by 117. So root over 13 by 117. So root 13 into 9 is 117. Okay. So this is root over 1 by 9. So that is 1/3. So 1/3 is a fraction. So that is a rational number. Okay. Root over 8 into root over 2. So root over 8 we can write as 2 to the power of 3 root over into root over 2. Now if we just remove the roots, it will come as so this is 4. So 4 is also a rational number. The 8th question is, insert a rational and an irrational number between 2 and 2.5. So very easy, rational number can be like 2.2. Okay, so 2.2 is a rational number, but irrational number is any number between 2 and 2.5 that is non-terminating and non-repeating. That will be an irrational number. Like I give 2.3469282453211. So this is a non-terminating and non-repeating decimal expansion because it is not repeating a same sequence of numbers. So it is an irrational number. So the 9th question is, how many irrational numbers lie between root over 2 and root over 3? Well, it's infinite. Infinite irrational numbers are lying between root over 2 and root over 3. Then it's asked, find any 3 irrational numbers lying between root over 2 and root over 3. Now, in terms of root, if we try to find out the rational numbers, then it will be little bit difficult. Okay. So, what we do? We try to find out the non-terminating, non-repeating decimal expansion of root over 2. So, it is something like that. Approximate value is 1.414, something like this. And root over 3 is 1.732. Okay, this is an approximate value of both the two irrational numbers. Now, root over 2. Okay, so you have to find out the irrational numbers between these two numbers. Okay, so rest of the work is very easy. So 3 irrational numbers between root over 2 and root over 3 are, one I will give as 1.512, 11512, 111, 519, 2. So this is an irrational number. Next I can give as 1.6 6 8, 6 8 8, 6 888, 6. So this is also a number that is non-terminating and not non-repeating, because a definite sequence of numbers are not being followed. Next number 1.712, 71122, 71122. So all of these three numbers are irrational numbers. So next is find two rational and irrational number between 0.5 and 0.55. So this is also very easy. So rational number too, it's very easy. So two rational numbers between 0.5 and 0.55 are 0.51 is a rational number because it is a it's a terminating decimal expansion, and 0.52 is also a rational number. So two irrational numbers between 0.5 and 0.55 are 0.5132, 51322, 5123. So this is an irrational number. Then next is 0.5312, 5322, 3322. So this is also an irrational number. You can make a non-terminating, non-repeating decimal expansion anyhow you maintain the sequence, okay, such that you see that all the numbers are not repeating. So that will make a non-terminating, non-repeating decimal expansion. So the 11th question is find three different irrational numbers between 5/7 and 9/11. Okay, so 5/7, first of all, it is in fraction. Okay, so until and unless you convert it into its equivalent decimal expansion, it is not possible for you to find out. So 5/7, let's find out what is the equivalent decimal expansion. Let us do as rough work. 7 sevens are 49. So 7 ones are 7. 7 fours are 28. So 0.5/7, that is 0.714, okay, is one decimal expansion, and 9/11, that is 1188. 11 ones are 1188. So 0.818. So you have to find out the decimal expansion between these two numbers, irrational numbers between these two rational numbers. So three irrational numbers between 5/7 and 9/11 are 0.72, 722, 722. Okay, in this way it will follow. And next is 0.75, 755, 755 is also an irrational number. Next is 0.801, 8001, 1800111. So this is also an irrational number. Next is the 12th question is find two rational numbers of the form p/q between the numbers this and this. So both of these are irrational number, as you can see, because they are non-terminating and non-repeating decimal expansion. Okay, so you have to find two rational numbers of the form in the form of a fraction between these two numbers. Okay, so the smaller number is 0.2020020002 and the larger number is 0.2121121112. Okay, so just find the approximation of these two numbers, then it will be easier for you to find out. So 0.202 is the approximation of this number and 0.212 is the approximation of this number. Okay, so first of all, the numbers that you will find out will be a terminating decimal expansion. Okay, so that will be a decimal expansion, then you will be converting into fraction. So between 0.202 and 212, two numbers you have to choose. So let's choose the number as 0.2024. Let us choose 0.204 and 0.206 that we choose. Okay, so then you have to convert it into 0.204 in P by Q form. How will you write? You have to convert it into fraction. You know very well there are three numbers before the decimal, so you will write the numerator as 204 and the denominator will be 1000. Okay, and so if you want to reduce it further, that will be 102 and this will be 500. If you want to reduce it again further, so 51 and this will be 250. So 51 by 250 is a rational number in P by Q form. And next is 0.206. So 0.206 in P by Q form is what? 206 by 1000, because here also there are two numbers before the decimal. So this will be 103 by 500. So 103 by 500. Okay, so two rational numbers are 51 by 250 and 103 by 500. Okay, so the next question is find two rational numbers between 0.16 and 0.17. So this is very easy. Two irrational numbers we have to find out. So two irrational numbers are 0.161, 1666, 111. Okay, and another number is 0.1623, 1622, 33, 2221. So this is also a non-terminating, non-repeating decimal expansion. The last question is, state in each case whether the given statement is true or false. So the first statement is, the sum of two rational number is rational. Yes, of course, it will give you a rational number if two numbers are rational. So suppose one number is 3, another number is suppose 4.2. So A plus B, if you do, 4.2 is also a rational number, 3 is also a rational number. So 3 plus 4.2 will give you 7.2. So 7.2 is a rational number. So from that we can say that the sum of two rational number is rational. The statement is true. The sum of two irrational numbers is irrational. No, not always. Because suppose if I give A equal to root over 3, B equal to root over 2. So A plus B equal to root over 3 plus root over 2 will give you an irrational number. But if I do a equal to root over 3 and b equal to minus of root over 3. Okay, so minus of root over 3 is also an irrational number. So if we just add these two irrational numbers, okay, so this will give you 0. So 0 is a rational number. So we will say that the sum of two irrational number is irrational is false. The product of two rational number is rational. Yes, of course, it will be rational because if I do a equal to 3, b equal to 2, so if I a multiply b, it will give you 6. So 6 is a rational number. So that is true. The fourth is the product of two irrational numbers is irrational. No, not always. Because if I do a equal to root over 3 and b also, if we take b is also root over 3. So a into b, if we do root over 3 into root over 3, that is, it will give you 3. So 3 is a rational number. So we will say that it is false. But if the question came like this, the product of two different irrational number is irrational. If it would have given in this way, then you would have given the statement as true because we are taking two different irrational numbers. So that will give you a rational number. But here we are telling that it is not mentioned that whether two same rational numbers or irrational numbers or two different irrational numbers. So we are giving the statement as false. Fifth question. The sum of a rational number and an irrational number is irrational. So what we will do, we will take let's take a rational number as 3 and an irrational number as 2. So if I multiply these two numbers, 3 plus root 2, so that will give you an irrational number. So the statement is true. Okay. A product of a non-zero rational number and an irrational number is a rational number. Okay, so let's check. A equal to 3, suppose b equal to root 2. So a into b, if I do, then 3 into root 2. So root 2 is an irrational number. So if you multiply this irrational number with rational number, it will give you an irrational number. So it is the product of a non-zero rational number and an irrational number is a rational number is false because it will always give you an irrational number. But if it would have if it is not mentioned that the product of this term is non-zero, suppose it would have given the product of a rational number and an irrational number is a rational number, then it would not have been it would have been true because if I say a equal to 0, 0 is a rational number and b equal to root 2, so a into b, if you do it would have given you 0 and 0 is a rational number, then it would have been true. So every real number is rational? No, because real number is classified as rational number as well as irrational number. So every real number is rational is false. Every real number is either rational or irrational? Yes, it's true because rational number is divided into both real number is divided into both rational number as well as irrational number. So the statement is true. Pi is irrational and 22/7 is rational. Yes, it's true because pi, if we consider the value of pi is something 3.1412, something like this. Okay, so that is a form of a non-terminating and non-repeating decimal expansion. Okay, so non-terminating and non-repeating decimal expansion is irrational. Okay, But for our approximation and to make our mathematical calculations easier, we are taking 22/7, that is just an approximation of pi. So 22/7 is a rational number as it is a fraction, but pi is irrational.